So today we're going to go over logarithms and logarithmic functions. Okay, so this is like an introduction to logarithms, and we're just going to go over how to write in log form, how to go back and forth from log form to exponential form. Okay, so let's do an example here. This is just generic form. Log base A of n equals b. So the way you read this is log base A, and the base is a subscript. It's a little number written at the bottom, toward like in the middle of your G. Log base A of n equals b. And it's always equal to the exponent. So this b represents an exponent right there. So if I were to write this in exponential form, it would look like this, where you have your base, the power, and it equals your answer. Okay, so notice the placement of all of those things. Your base is A, the exponent is B, and then your answer is N. Okay, so let's do one with real numbers. And before I go on, let me just tell you this. For the purposes of this chapter in this class, the base and your answer, these two things here, are always going to be positive. Okay, so that's not really going to be that important today in this lesson, but as we go on and do more things with logarithms, then it's going to be more important later. Okay, you're going to need to remember that. Also, the base A is never going to be equal to 1. You guys know why the base would never be a 1?
Because
1 to the millionth power is going to be 1. So it's not really, there's nothing that you need to use a log for to figure out what exponent you're using for a 1. Doesn't matter what exponent it is. It's always going to equal 1. So let's look at the first example. Log base 3 of 243 equals 5. And all they want us to do on this first example is change it to exponential form. Okay, your base is 3, the exponent is 5, and it equals 243. 243 is your answer. So that would be an exponential form. The base is 3, the exponent is 5, and then it equals 243. Any questions? So let's do another one. Let's do like number 4. Log base 5 of 1 over 25 equals negative 2. So to write that in exponential form, this is in log form right now. To write it in exponential form, I have the base, which is 5, exponent, which is negative 2, and it equals 1 over 25. Any questions? You guys see another one on there from 1 to 5 that you want to look at that we haven't done? Everybody got it pretty good? Okay, so in the next part it says change to log form. I know this seems pretty simple, but it's really important to know how to change it back and forth, okay? So on the next part, we're going to change to log form. Number 6, we have 2 to the third equals 8. So we're going to write log base 2 of 8, whatever the answer is, equals 3. Always equals the exponent. If you're writing the logarithm and it doesn't equal the exponent, then you did something wrong. You wrote something incorrectly. You guys see one from 7 to 9 that you want to do together? Think you got it pretty good? Yeah? Okay. Let's move on to the next part. To evaluate logarithms, change to exponential form first. So log base 5 of 25, you would think 5 to what power equals 25? And so this is kind of like what we were doing yesterday, really. Okay, so on number 10, you have log base 9 of 3. And they want you to figure out what the exponent would have to be for this to be a true statement. It's not equal to anything. Yeah, let me go through the steps though, because I want you to know the steps whenever it's a really easy problem, because when they get to be harder, you're going to need to do the same steps to get to those answers. Okay, so what I would do is you can set this to just like a question mark. And some people use a variable, but when you start getting variables in the problem, that gets a little confusing. So I like to keep it a question mark so you know that this is what you're solving for right here. What is the exponent going to be? So now let's write it in exponential form. 9 to what power is 3? Okay, so just like we were doing yesterday, we want to rewrite each number so that they have the same base. So this 9, I could write it as base 3. And it'd be 3 squared, but then I still have that question mark, equals 3. And now the bases are the same, so I can set the exponents equal to each other. So what is the exponent going to be over here on the right side? 1. So I got 2 to what times what equals 1, divide by 2, and so your exponent has to be 1/2. Okay, so as your problems get harder, you still want to do the same steps to get to your answer. Let's do one more. You guys see one on there that you'd like to do? 16? Okay, on 16, there is no base written on number 16. So when they give you a logarithm like this, the base is understood to be a 10. All of the logarithms that don't have the base written are in base 10. Okay, so then you can go on from there and solve it. So 10 to what power equals 1,000? 10 to what power equals 10 to the third? So the exponent has to be a 3. Any questions? Well, let's do, you want to do 12 or 15? Or 14? 15? Okay. Log base 5 of 1 over 125 equals what? So 5 to what power equals 1 over 125? Anytime you have a fraction, if you want to write the base as a whole number, you have to use a negative exponent. So that would be negative 3. And then your bases are going to reduce out, so your exponent has to be negative 3. No. Any other questions? Alright, so for the graphing part, there are two types of graphs that you're going to have for logarithms. One type of graph is when the base is greater than 1. It's going to look one way. Okay, so there are 3 easy points that you can get when you have a simple logarithm like this. And this is your y, of course, is f of x, log base b of x. So your 3 points that you can get is just using your base. You're just going to plug it in. 1 over b, negative 1 is 1 point. 1, 0 is another point. And then b1 is the third point. So let's do an example and graph it. I'm going to make the base just a 2. You don't have to use your calculator for this or anything. You can just plug the base in to these 3 points that I gave you. So this first point would be 1/2, negative 1. 1, 0, that always stays 1, 0, that never changes. The other two changed according to what the b is. And then the last point is 2, 1. Okay, so graphing those points, 1/2, negative 1, 1, 0, and 2, 1. So your graph is going to look like this. Okay, so on these graphs, The x, the domain, is the one that's going to be restricted. And your y is going to be all real numbers. Because your x needs to be a positive value, and then the y is, all of the numbers it can be. Okay, now your second type of graph is when the base is between 0 and 1. It's a fraction, like 1/2 or 1/3. Okay, you're still going to use the same 3 points, but it's going to change because now the b is a fraction instead of a whole number. So let's plug in an example. F of x equals log base 1/3 of x. Okay, so this point b1 would just be 1/3 1. Then 1, 0 stays the same. Then your last point, 1 over b, what's going to happen with that one? You're going to have 1 over 1/3. What's that going to work out to be? 3.
Well,
When you divide by a fraction, you have to flip the fraction and multiply it to the top. It's like, you can write it out sideways if that helps. 1 divided by 1/3. So you got to flip that second fraction and multiply. It's going to equal 3. So that third point would be 3, -1. Okay, so let's graph those. So this graph is going to look like this. So it's kind of like when you have a exponential growth or an exponential decay. The graph changes when your base is in between 0 and 1 as opposed to being greater than 1. Now there are some transformations that can take place. And in generic form, your transformation equation would be like f of x equals a times log base b of x minus h plus k. So the h is going to cause your graph to move left or right, and the k will cause your graph to move up or down. And the point that I use to move the graph around is this point 1, 0, because that always stays the same. So when you have a transformation going on, you can think about, okay, well, it's going to start here, and then the h is going to make that move left or right, the k is going to make it move up or down. The other 2 points that you get from your base, that's going to be kind of convoluted because of the whatever happens with the a. But this 1 point, 1, 0, you can always start there and then move that point around however it's being transformed. But we're not going to do any like this that has an a in front. I just want you to do some simple log graphs just to kind of get used to it. Okay, and then we'll do some other ones, some harder ones later.